Hello everyone, welcome back to the series Object Oriented Design Patterns. In this particular video, I'll walk you through factory design pattern and its implementation. What is factory pattern? Let me give you a general example. Imagine you felt hungry when you are in your home. Then what will you do? You'll go into the kitchen and prepare some food for yourself. In that case, think of there is a machine in your home which knows how to prepare all types of dishes. You just interact with this machine to get the food. This machine knows how to prepare a pizza or a burger or a taco or anything else. That means this machine will act as an interface between you and all the products which needs to be made. In factory pattern, the machine is called factory, and the make pizza, make burger, and make taco are called the products. And this is called factory design pattern. Let me put it in technical terms. A factory design pattern is a creational pattern that provides an interface for creating objects but allows subclasses to alter the type of objects that will be created. To break this definition into two parts, part 1, the factory design pattern provides an interface for creating objects. If you see, the machine will provide an interface between the user and also all the products. And coming to the second part, it allows the subclasses to alter the type of objects that will be created. A user will not ask for the same product every time with the machine. That means you can change what needs to be created from the machine based on the user request. Think of you will ask for pizza once or burger once or taco once, but you will ask for the same machine. That means the machine is creating different kinds of products based on the user request. Similarly, in factory design pattern, the factory will create different kinds of products based on the caller request. Now, let's build a payment service. In this particular service, these are the minimal requirements. 1. Build a payment service system. This is the payment service which is used in any checkout service. This service should support multiple types of payments like credit card payment, debit card payment, etc. Next, the system should be flexible and scalable for the future requirements. And the system should obey open close principle and abstraction. We'll see what are these when we start implementing this service. Now, the service which we are building, we don't care about the implementation of how credit card payments work or debit card payments work or UPI works. The main goal is to illustrate factory design pattern in payment service. How are we going to deal with different kinds of payments in this particular service? Now, let's build the payment service. These are the three requirements the system should support. As we write down all our requirements, we need to go with what are the objects that will be required in this system. That means we need to write down what are the classes required in the system for the better view. We are implementing this using factory design pattern. We'll definitely have a factory. And we'll have the products. What are the products in our case? The payments or our products. Now, our or this payment service will be used in any checkout service. This is our main code. Okay, I think we are good. These are the mandatory objects we need to have in our system. Let's build the payment service. We'll start with the products. Now we need to have uh, a general contract between all these types of payments, because if we want to add any new payment, the object should be mandatorily have some behaviors in it, like uh, process payment. This is one of the method which needs to be there in each and every payment. That means we need to hook all the products under one tree. This is where interfaces comes into play. Interfaces will provide contract between its child implementations. So before implementing the concrete products, we'll start with interface. This is an abstract class. An abstract class will only have definition, it does not have any implementation. Now, this payments interface will have the mandatory methods. I have added the abstract method decorator over the process payment. Now the process payment is an abstract method. It will not have any implementation inside it. It is only a definition. The products, the credit card payment or the debit card payment, everything will now be implemented using payments interface. This will make sure that every child for payments will definitely have a process payment, or else the execution will throw an error. Similar to credit card payments, we'll have the debit card payments and the UPI payments. These are also implemented on top of payments interface to provide that contract. Similarly, we do the same thing for UPI. I hope you got the idea for the UPI. Now, let's build the payment factory. In this payment factory, this is responsible for generating the payment object. This will definitely have a generate payment method.
Think of this for a second. The user needs to request to the factory what kind of payment it needs to generate. Like if the payment wants to process the payment using credit card, then the user will throw or the user will provide the argument as a credit card. Let's take it as payment type. This is one of the argument. Now this payment type, we will see if it is credit card, then we will return the credit card payment object. So how can we do that? We can maintain a dictionary. For that, this is the simple way, so that we can look out inside this dictionary and we will return the necessary class or necessary object. Next, we'll take a look at the payment type and we'll look up in the dictionary. This will return us a method. Maybe if the payment type is not allowed, then we need to return something, so that we'll change this to get. If the payment type is available in all types dictionary, then we'll return the value of it, or else we'll return none. Check if the payment object is valid or not. Will return the payment object, else we need to return, we can throw an error. The payment is not allowed. Next, we'll take a look at the checkout service. These are payment factory. To brief, the generate payment method will take a payment type as argument, and this will be lookout in all the payments, and if it matches with any of our payments, then we will return the payment object for it. We are good with the factory and all the payments, the products and the factory. This is our system. Now we need to integrate this into any one of the checkout service. So let's build a sample checkout service. Then we have a checkout method inside it. Whenever we want to check out, we need to have some things. We'll have an amount which needs to be paid. This will be an integer, and what is the payment method chosen by the user. Now we will request the payment factory to generate a payment object for us for this payment method. So this will generate a payment object. We will just implement the payment object's process payment method. This might be also none, because if the payment is not available um, in uh, in this particular dictionary, all types, then this will throw none. So we'll check it. If there is no payment object, then we'll just return our execution by logging the error. Okay. This is our entire execution. We have a checkout service. We have a checkout service and a factory, and we have all the payments. Let's start executing this code. Okay. Or maybe we can start with using interpreter. I'll import the checkout service. Now the checkout service will create an object out of it. We want to make the checkout. I will add some amount to it, maybe 100 rupees, and the payment method will be of type, for now let's choose credit card. If you see, processing the payment for credit card, this is our concrete method, a concrete method returning output. This is the return output which we are seeing. That means this is working fine. If I choose to check out using debit card, then it is executing this part of the code. So what is factory design pattern? So this factory design pattern, this payment factory is providing an interface layer between checkout service and all the payment types. Checkout service does not know anything about the payments or how it is implementing, what is going to happen inside of it. The factory will take care of that abstraction layer. Next, part 2. The checkout service will always interact with the single payment factory, but the payment factory will create different kinds of payments, like it will create debit card payment or credit card payment based on the checkout service. This is what altering subclasses based on the user's request. I think we are good. Now let's validate our requirements, whether they are actually obeying all the conditions with our implementation. Let's go through our requirements once again. 1. System should support multiple payments. Yes, our system is supporting different kinds of payments. Next, the system should be flexible and scalable. Yes, this system is scalable because if I want to add any new payment, I can just simply add a new class over here by implementing payments interface. Similar to like this, we can add UPI and another class. Next, system should obey abstraction and open close principle. Now, let's take a look at the interface. This interface is providing an abstraction layer between payment factory and credit card payments. I can show you a small diagram for better understanding. If you see closely, any client module should not directly interact with concrete implementation. It should always go through an abstraction layer. Either it is an interface or an abstract class. This is called dependency inversion principle. This is one of the important solid principle. So by this we can say the abstraction, we are providing an abstraction layer between payment factory and credit card payments, and we are also providing an abstraction layer between checkout service and concrete payments by implementing factory in between them. Now let's see open close principle. Our system is actually obeying open close principle or not? Well, not really, because think of if I want to add any new payment service like UPI. Let's implement a UPI payment service to get more idea why our system is not obeying open close principle. Class UPI payments and after this, we have added the UPI payment by implementing payments interface. Next, we need to update this all types dictionary with UPI payment. What is open close principle? Any class which is already implemented, it should always open for extension but close for modification. But what we are doing here, this is modification. We are going inside the class and changing some parts of the code. This is not right. This is not obeying open close principle. That means the point of having a dictionary over here is not a good idea, is not a good execution. What should we do? Let's think of what are different possibilities we can have without having a dictionary, so that we don't need to go inside every time whenever we want to add a new payment to update this particular dictionary. Let's write it over here. Type 1 is having a dictionary which is not obeying open close principle. Next, type 2. One thing we can do is we will loop through all these payments. I mean, what are the classes which are implemented on top of using this interface. We can loop through all of these and we will find the suitable payment service, and we can create an object through it. Loop through each of the implementations of each of the payment implementations, we can say. This is not this is not good because every time we are looping through each and every payment, each and every payment method. I mean, we don't need to do that because we are looping exhaustively for each and every payment. That is not what we can say. Um, that is not good with the time complexity. Yeah. Next, another type, runtime execution. We can add a couple of methods for this payment factory to update this particular dictionary at runtime. What I mean is, let me show you. I'll make all types as a class variable. Let's remove this from here, and this is self. I will add a method to add any new payment into all types. We will pass both payment name and a payment object. We'll store them in the all types dictionary. And we can add one more method, like if I want to remove any type of payment, then I can just simply remove. This will work. What I have done, I have replaced all types static code into two methods. One is add payment and another one is delete payment, so that we can use these two methods to alter the contents of all types at runtime. Next, we are not dealing with payment factory. We are actually dealing with the checkout service. I mean, the checkout service is the orchestrator of this flow. So, we need to pass payment factory as an argument when we are initializing the checkout service. And this pay factory is of type payment factory. Now, this payment factory is not just any class. This is the class which we have taken. To summarize what we have done, we are passing payment factory into the checkout service. Prior to passing to the checkout service, we will prepare a factory with self.all types. I mean, we will include what are all different types of payments which this system supports into the payment factory, and then we will pass the payment factory into the checkout service. Let's look at the execution to get good understanding of how the execution flow will work. Let me start the interpreter. First, we need to import all the payment services from the factory, and we will add these payments, all the types of payments into the payment factory, and then we will initialize our checkout service. Let's see how we can do that. From here, we will import credit card payment, debit card payment, UPI payment. So we have imported all these three payments. Next, we'll import payment service. Payment factory, sorry. Let's initialize the payment factory. Now I want to include all these payments into the factory. We use the method add payment. And we'll pass credit card payment. This is the object, and the name will be credit card. Similarly, we also pass debit card and UPI. Now our factory is ready. We will pass this factory into the checkout service. For that, we need to import the checkout service. Factory demo. Let's initialize the checkout service. We will pass the factory as an argument. Our checkout service is ready with the factory, and this factory is capable of handling all three payment methods. Let's execute this. This variable, the checkout service class has a method checkout, and we will pass how much amount needs to be paid. Suppose it's 100, and what is the payment method we are looking at. Let's consider for credit card. Done. You see, this part of the code has been written. That means our execution is working well and good. So what we have done, at runtime we have added all different types of payments into the factory. In the same runtime, we have passed this factory into the checkout service, and we are able to check out using different kinds of payments. So to summarize, this is how we will implement factory design pattern where we need to obey open close principle, abstraction, and the system needs to be scalable.
Where can I use factory design pattern? The places where object creations requires a lot of decision making and conditional logic. At that places, you can separate the object creation from the main code and add a factory interface between the main code and the different kinds of products. Then at that particular place, you can definitely go for factory design pattern. With this, we have come to the end of the video. Thank you so much for watching the video. I hope you enjoyed the video and I'll see you in the next video. Bye.